So, a month ago I created a video on transferring my game from Unreal Engine to Unity. A lot of you seemed to enjoy it as it quickly became my #1 video, and so in today's devlog we'll be continuing on my project. More specifically, the water system. Now, if you're new to the channel, first of all, hello. I am an indie soul game developer currently working on Tranquil Waters, a casual exploring game set in the 17th century with pirates. Without further ado, let's get started. Now, as you can see, we do have water and some cool waves. Also, ignore the shift wheel, it's still under development. So what are we exactly missing? Well, the problem that we have is that we're only showing the water, it's not affecting the objects in the water. The reason why is that I've written the current water system in a shader, which is a chunk of code that gets run on the GPU, but our game is run on the CPU. So that is why we cannot easily access the height of the waves however we want. And this is what I want to tackle in today's video, so that hopefully by the end we have a proper water system. So my immediate thought for solving our problem was something called a compute buffer. For you who don't know what that is, it's also code that gets run on the GPU. But a compute buffer is designed to calculate some data and send it to the CPU, which is perfect for what we need. So I got started on transferring the logic of wave heights from our old shader to the new compute buffer, which was actually more difficult than I expected it to, since there were some things that I couldn't access in a compute buffer, but I could in the shader. And it was just a bunch of mumbo jumbo, but I will spare you the pain it caused me and just show you the final result. Now that we have access to the height of the waves at a specific position, it's not really difficult to find the closest point. I wrote this block of code that retrieves wave height. Now it is pretty inefficient since we are looped through more than 10,000 points every time we call the function, but it should give us something at least. Now I did try optimizing it further, like getting the index of the array from the position of the point, but it did not go as planned, and I left it on the back burner for now. Now I think we've come to the part of the video where I can say, if you liked the video so far and want to see me suffer more with game development, make sure to subscribe and potentially move the cursor more to the right and like the video as well, because it honestly does help, especially with my moral boost. And let's just continue with the video. I wanted to test out and compare the CPU version of the wave heights and the GPU version to see if they match. And as you can see, no, they don't really do that. Now this could simply mean that the Perlin noise values are different, which causes this to kind of overlap. Now I finally realized that I do not need to set the waves from my old shader. I don't know why it took me so long to figure that out, especially since it only took one line of code. So yeah, that's what I did, and as you can see now they match perfectly, obviously because they get the wave height from the same source. So now we're finally getting closer and closer to our perfect water system. I wanted to go back to our wave height function just one more time because it's pretty bad. So I rewrote the entire thing for like the third time, and now I can set how accurate I want my height to be, depending on this search radius variable. So obviously the higher this value gets, the more accurate the result is, but it also takes longer. The ship is floating correctly, and now before you type in the comments, I know it looks weird, but these are all variables that I can fine tune, like for example the angular drag or the displacement amount and so on. So it's not a big deal, I promise you. The final thing I wanted to fix is this weird effect that we get when part of our ship is below water. See, that shouldn't really be happening. So to fix this was a bit more complicated than what I initially thought. I'm basically using a cube to sort of mask out where the water shouldn't be. So this is the first time I've ever played with something like this, and I feel like it turned out to be pretty okay. we do get this very weird effect, which looks very trippy, but we don't have to worry about it since it's something the player will never be able to see anyways. But yes, this was all I wanted to show to you guys today. If you have reached this far, it doesn't hurt to subscribe, you know, and maybe even like, but that's up to you. But truly, thank you so much for watching, and also for dropping these heartwarming comments on my past few videos. I truly have no words for it. But yeah, thank you so much, and I will talk to you in the next one.